So, Philippe, you can start. Okay, I have started the recording now. Okay, just introduce yourself and let's start this. Uh, we have already the audience on YouTube also, so you can start.
So everybody can hear me. Hello, everybody can hear me.
Yes, yes,
Okay, great. So hello everybody. Thank you for joining today's East Good Friday. Thank you for everybody joining. So today I'm going to start share my screen. Uh, can I share my screen?
yes, 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 Philippe.
Okay. So one second. So today we all have joined. Can everybody see my screen clearly?
Yes, yes, Philippe.
Okay, so it's unit, circle, and trigonometry. So today, so the reason we all joined today is because we all want, most of us want to know what is unit, circle, and trigonometry. Because I personally, I had a lot of difficulty learning this topic of trigonometry in class 11th. As from 10th class in CBSE to 11th class, there's a big difference. In 10th class we have some small easy angles to learn: 30 degrees, 45 degrees, 60 degrees, and it's up after that 90 degrees and max, and after that it's over. But when we came to 11th class, it became really difficult. It's suddenly theta plus 45 degrees, and like that all different kind of combinations came. So I found that difficult, and so I had to study for that. So God's grace, after studying for it, and now after like passing our 12th, I kind of got an idea of it. I'm not a super expert in this. I'm not like a super expert, but I can kind of give an idea from a person who has tried a lot. I've tried a lot of combinations, and I try to understand this concept in many different ways. And now I'm like I can explain it. So the main topics we're going to learn today is: first is unit circle, how it operates; second is how a trigonometric function it works on the unit circle; third is like large angles, like some 1,000 degrees and all. How do we find that all in a unit circle, and using how do you find such angles in a trigonometric function? And fifth is kind of interesting thing: how do we prove graphically? Because we've all learned sine square theta plus cos square theta is equal to 1, but we're going to now try to prove it graphically. And I'm not even going to try to prove it like that. You all will be able to understand how it happens. So that's how that's the main aim today. So before we start on, actually, I'm having my, if I off my video, I probably think I can have a better. So I might off my video. Okay, because I'll be more like easy for me to say. So before we start on
Yes,
unit circle, I would love to explain. I would love to ask a question, and I would love to ask, what is a function? Because unit circle and trigonometry, all these all are functions actually. So it's all these all values we see: trig based on triangles and trig functions based on unit circle, they all are functions. So my question is, what is a function? So and I had a lot of difficulty understanding it until my sir explained it. So my sir explained what's a function. Function is nothing else but a machine. You should think of it as a machine. And now we are all as data science and engineering students, so a more easier way to say it: function is nothing else but a program, a programming language, which has a compiler is our head. Our compiler is the head. Usually in a programming language, the compiler is the machine itself, which will give out the output. But in for the function, the compiler is nothing else but a head. We have to use our own head. We should compile the answer and give it out. So for a function, we give in some values. For example, for a trig value, we'll give in some theta value and we'll get out a function. And meaning for we'll give some degree value and we'll get some output out. And for any other function, like for modulus function, we give some negative value, a positive value will come out. So same way. So this is the fun part. The compiler is ahead. We should imagine what will be the answer. So in a generalized version, we will get out a graph. In a generalized version, for example, I'll show over here. I'm sharing my screen over here. For a generalized version, we'll, for example, y is equal to x, y is equal to s. As we can see over here, there's nothing else but a compiler. What's the function is y is equal to s. So as we can see, if we change the value of, change the input, we'll get a different input. Yeah, yeah, can you see, can you all see? So instead, now this is a generalized version. Suppose we want to find that at s is equal to 2, we want to find out what's the value. So if s is equal to 2, we'll put the value of s inside instead of this generalized version. So and then we'll try to compute. So we'll go in ahead and we'll find s is equal to 2. So it'll be s minus 2, that's equal to be 0. So 0. So the value of y at that point is going to be 0. And if you check over here, uh, if we check the value of y over here, it is going to be 0. So that's an interesting thing. So that's a easier way. Now coming back to our unit circles, now I'm coming to inventors of the trigonometry. Why is trigonometry very important for us as Indians? Because most of trigonometry was actually made by Indians, and there are a lot of mathematicians of India. Over here, I've just named two of them. After there's the Hipparchus is the, he's considered the father of trigonometry. He came from Greek. He greatly influenced Aryabhatta and Brahmagupta. They both are like, they learned, they got, when the Greeks came to India, they came with some knowledge, and these people, they learned everything and they built on that. So they built on that, and on top they developed, for example, Aryabhatta the first, he introduced the sine function, and he also he provided methods for calculating it. But then after him, his successor came, his successor who came after him, he developed formulas for sine and cosines. Then after that, what happened is, when the Mughals came to India, and they came to India and the Persians came to India, all this knowledge that the Indians had collected, that is Aryabhat, Brahmagupta, then there's Bhaskara the first, Bhaskara the second, and they all collected all this knowledge. The Mughals came, and the Persians came, and they studied it all, and they had huge libraries in Iraq and Iran. So over there, all this information came, and all these Persians, they learned Hindi, they learned Urdu, they learned the Vedic ways, and then they started to understand how we thought. Because all the Aryabhatta and Brahmagupta were great astrologers and astronomers, so they could read the stars, and they were developing new ways. So now, like that's how deep the Indian influence has been on trigonometry. Now we are coming to the basics of trigonometry. We all know the basics of trigonometry. In fact, the previous to this, there was another lecture taken by a fellow student, and he came and explained all the basics of trigonometry. I would highly recommend you see that video. It's present on YouTube. It's in the Pi Square YouTube channel, if you check it out. So we can see over here, I'm now going to share, I've got a writing tab. So hello everybody, wishing you all, I hope you can see this writing tab.
Yes.
So so we all, so everybody, welcome, hello BS students. Now we are now going to discuss the all the topics. So we all know that, sorry, wait, that um this is the right angle triangle. The perpendicular, it has a perpendicular, adjacent, and a hypotenuse. So we have been taught from earlier only that sine theta is equal to perpendicular upon hypotenuse, cos theta is equal to adjacent upon hypotenuse. These are some basic 10th class, some people study it in 8th class. All these new all topics, these are all old topics. Now my question is, how do we get this? We got this mainly uh, from the circle. Actually, if you look at a circle, this is how a circle's formula we found out. We know this is called theta. This is called r, l. So the arc formula, l is equal to theta into r. Now, based on this, when we make theta small enough or great enough, I'm not, I've told you I'm not an expert in it, but I believe that's how we found out the sine theta formula. And how can we, there's an interesting way of we verify that the L is equal to theta into R. Is that correct? Is by checking the circumference formula. What is the circumference? 2 pi R. 2 pi R is nothing else but the entire circumference of the circle, right? So over here, 2 pi is the angle and R is the length. So that's how we have verified that, okay, fine, this is the circumference. So based on this is how we got the circumference formula, by the way. So uh, now, um, now let's so we all know the basics. So sine theta is nothing else but perpendicular by hypotenuse. Cos theta is base by hypotenuse. Tan theta is perpendicular upon base. Yeah. So tan theta is nothing else but when we take the sine theta and divide it by sine theta upon cos theta is equal to tan theta. Some basic things. I hope we all know this because if you don't know this, you can watch the previous lecture which was taken in the pi square seminar. They have explained it well over there. Now, coming to this new topic, what is a unit circle? Because that's what I started my conversation with. We're going to explain a unit circle. Unit circle is nothing else but a circle at the center, at the original or origin of the number line, with a radius of 1. The the radius of 1. The so the thing is that if let us imagine this is the number line. Okay, so if we take a radius of 1, I'm sorry, the picture is not perfect. Let me try to use a more better way. Okay, somewhat better. Okay, okay. uh, Now imagine this is the number line, and this is a radius 1. So this is at 0 comma 0. This will be 1. This will continue all the way to positive infinity. This will continue all the way to negative infinity. So when we come to and check it out, actually the unit circle is a way that we are able to merge both the number line. So number line is whenever we study number line, it comes in algebra, meaning it is different from trigonometry. We usually don't put it in we don't put meaning numbers into the sine function because like we have not seen sine 1 is equal to what, we don't know that. But everybody like sine 90, if you put sine 90 is equal to what, we don't know. But if we check sine 90 degrees, then we are able to find out the answer, and the sine 90 degrees is 1. So we know that answer. But sine 90, now 90 is a number that is present on the number line and we don't know that answer. But now comes this concept called the unit circle, and unit circle is a way that we are able to take the entire number line and we transfer it. It allows us to understand radians a bit more. It allows us to understand trigonometry a bit much better. But this is the new way we are trying to solve. So I'm coming back to my PPT slide, and sine theta and cos theta. Now, what are the uses of it? Look, it helps us define sine theta, cos theta, and tan theta for all angles, and it helps us to understand trigonometric function, periodicity, and it's used in geometry and physics and engineering quite a bit. Now, in order to understand what's the unit circle, because I just now mentioned radians and degrees, let's just understand what's a degree and what's a radian. So degree is nothing else but this. A degree is defined as 1 by 360 of a full rotation. 1 degree is nothing else but 1 by 360 of a full rotation. That's why we can check it out that sine 90 is at wait a second. I'll just clear my screen so that we all can. So we know that sine 190 degrees is this. We know this is 90 degrees, and this is like exactly perpendicular or exactly perpendicular to the line. Sine 180, I mean, sorry for saying 180, but 180 degrees is one straight line. This is going to be 180 degrees. 90 degrees is going to be this. 180 degrees is going to be this. And 360 degrees. Now, 360 degrees is supposed to be one entire clockwork. We know that because the circle is three. When from the center of the circle, if you try to find out the angle, this is going to be 0, 90, 180, 270, and 360. That is by keeping this point fixed, point A fixed, and point A O fixed, point A. So when we go this is going to be 90. This is going to be 180. This is going to be 270, and this is going to be again 360. So 0 is equal to 360. So this is called comes in degrees. These all are in degrees. It is not in radian. But now when we check out radian, what is radian? A radian is the angle subtended at the center of a circle by an arc whose length is equal to the radius of a circle. So this is a totally new definition. What does this do? This gets rid of the degree. It allows everything come down to fractions. If you check it out, and the last point is written, radians are unitless. So that's the thing. Radians are unitless. So hence we are able to see, we are able to take the entire number line and put it on the unit circle. I'll just check it out in the next slide. We are trying to say understand how it happens. And look, over here I've written it entirely, I've written it down, but I'll try to explain it the more easier way. So I will, okay, so coming back over here, so we, one second. Okay, so let me just go up. Okay, so here we come, a unit circle. So this is the positive infinity, right? This is the negative infinity. So in order to understand how we can do it, there are two ways. Either we can imagine the unit circle as a wheel. Okay, I found it quite interesting. Suppose we imagine it as a wheel. Okay, imagine unit circle as a wheel and roll the wheel. We roll the wheel towards the positive infinity. So at this point, at this point we're at 0 comma 0. This point, look, assume the center is O. This point, name it A. This point B. Okay, so A is at 0 comma 0. This radius is going to be of n units. Call it n. Wait, let me just expand it so that it's easier to see. So one second. Okay, okay. So if you guys can see, it's written n, right? I hope you can see in the screen. But so this is n. Now what has happened is that suppose we roll the ball, this will go exactly n distance because it's a perfect circle, right? It's a perfect circle. So if this is n, so no matter how much it rolls, it'll roll exact this much distance, n distance all the time. So this will land up at n, and so the ball will land up over here. A will be over here, B will be over here, and he will be exactly n units away from the circle. So I've not drawn it exactly properly. I've not drawn it exactly properly, but you get the idea. It will be exactly at n. So by if you do it like this, the next time it'll be at 2n. Next will be 3n. Next will be 4n. So if you notice that by 4n, this a has gone from here to and the first a was at the bottom. A has moved over here. Now a will be over here. B will be over here. Then now a will be over here at 4n, and B will be on the top. And now in the last, by the fifth row, this is the first rotation, second rotation, third rotation, and the fourth rotation. By the fourth rotation, A is back on the floor and B is over here. So as we can see, we're wrapping every number on itself. I'll just on my video because I'm not unable to actually tell. Hope you can see the. I'll just stop the presentation for a while, and I want you to like see if you can see me. So just imagine this is the. I'll take one second. just imagine this is the number line, the unit circle. So this is the positive axis. So suppose we start to roll in this side, we are wrapping all the numbers around this unit circle in a way that all the positive numbers, if we like, either we can roll the thing like this, or we can do even better. We can assume that the number line is a string, and we start wrapping it the anti-clockwise way. So we wrap all the numbers in the anti-clockwise ways. What will happen? All the numbers will start to fall exactly in the same line. So it'll be like 0 here, then like I told you in the thing in diagram, n, then 2n, 3n, 4n, like that. It continues to happen. So one, so by doing that, all the numbers will just line up one. So eventually it'll be like this. So zero, after zero will come like 100 or 200, 1,000, even to infinity. So we can just keep on wrapping every number. Now why is this useful? This is useful when we are coming to radians and large angles. By this small wrapping technique, like if in the anti-clockwise direction, all the positive numbers; in the clockwise direction, all the negative numbers. Because this can roll backwards also. Like a wheel can roll both forward and backward, right? So if you go in assume this is the positive direction, all of these numbers are getting just imprinted on this. Now if it goes in the negative direction, all the numbers are getting imprinted on this side. And that's the thing, it's a function, right? And function has the main compiler as a brain. So we are able to visualize that, okay fine, all the negative numbers are coming on this. If you go in the anti-clockwise direction, I'll try to write it down. I'll try to write it down over here. So once again, I'll just clear my screen. So yep, so this is the circle. Actually, I'll try to draw a better circle because they have given us there's a way. I'll try. I'll just rub this and draw a better circle. Sorry. Oh, wait. Yep. Okay. So smart drawing. I want a circle. Yep. So he's drawn an ellipse instead, but you get the idea. So when we now, assume this is the positive axis, negative, positive. Assume this as a rope, and now we just take this and wrap it. So we keep on taking all the positive values on this side, and we just wrap it. This is 0. Assume this is a distance at 10. Let's take it 10 instead of n. So this will be 0. Then we have moved. I think so. If this is 10, so that means this will also be 10. That means this value over here. Just change the pen color. This value over here will be 10. This value will be 20, 30, and comes here 40. And then it continues again. This will be 50, 60, 70. And as you can see, these numbers are not going to end. So eventually, like assume we have done 1,000 times we have gone. So this will value can be like, I don't know, 7,000. So just imagine, it can be any number. Or this can be like 50,000. Or like just say it can be 1 million. So all the numbers are getting wrapped up over here. That's all great. But now coming back, if we imagine what about the negative part, because we know that the wheel can go both positive way and a negative way. So let's if we imagine about the wheel. So let me just rub most of the things. This is the negative part. Now suppose we wrap this way. As we can see, will be 0 comma 0 still. This again, let's take this 10 units. Okay, the units are 10. It is Unit, the radius cannot be negative, right? So units is 10, so this will be minus 10, minus 20, minus 30, minus 40, and you can continue like this. It can become minus million. For all we know, it can be minus 5 million, all the way. It could be minus, can go all the way. If they are into like infinity circles, they can be minus infinity over here. So it like this. So this is how the unit circle operates, and by this we're able to bring radians and we're able to merge it. Now coming back to the slide,
So,
so
excuse
this is
me.
all. Yeah.
Um, is this a unit circle that you are referring to? Or
Can,
can you go to the
one second. Can you repeat the question?
can you go to the
Okay, I'm going to the.
drawing board?
Okay, fine. I'm on the drawing board. Yeah.
Is this the unit circle you are referring to?
I would be. No, I'm trying to explain the unit circle and the number line having a relationship. But yes, this is we
Actually,
can. Uh, uh, yes, this is the unit circle that I want to explain in trigonometry.
this is not a unit circle. Unit circle we have a radius one.
The units. Okay, fine. I'm sorry. I'm
Uh,
sorry. This is not a unit circle, but the for unit circle we have the radius 1. Yeah, I made a mistake, but the thing is that we can take any radius. Like for example, I've taken a radius of 10. We can take a radius n can be at any general value, and we can make the radius the unit circle. Why the reason I'm trying to explain the concept of the unit circle. The reason they have said the unit circle is because all the values in the function, in the values that are given out by the function of sine theta and cos theta are all mainly in the brackets of -1 to 1. So that's why I believe I'm repeating again, I'm not a super expert at the value, but I believe the reason why it's called a unit circle is because they have chosen the values for all the functions to for all the function because sine theta and cos theta give the values between -1 to 1. And I would love to actually reach that part in the I've got Desmos over here, so we'll be able to explain better. Actually, let me just go there. Okay, so at Desmos, let if we show y is equal to sine A. So we can see all the values over here are between 1 and -1 for sine theta. So I actually don't know the reason. This is a great thing you can do as a homework to find out why they use the unit circle as 1, because we can use the units. Actually, we can find out because all the values of sine are from 0 to infinity, so it can be any value we can put inside. But the unit circle we use especially is because probably most likely to get the basics, to get the meaning, to get all the functions inside. If you change the variable, we can actually get the values also, but it'll be a little more difficult complication, difficult computation. But I believe that we can still using the different radius. Like over here I've used the radius 10, right? So using this radius also we can probably get sine function and cos function, but it'll be a more difficult way to do it. But I believe we can still do it. But to get to reduce the computation, they put the unit circle at the radius 1. But what with the main purpose of this image, I'll try to be short in this. But the main purpose of this image is to show the relationship. Is to show the relationship between a number line and a circle. So this is how the advanced the mathematicians at that time, they're able to crunch down huge numbers by just using this circle. And one more thing about this circle is that if you check the I'm not going to be able to explain it because honestly, to explain it I have to be more better at the topic. I'm not as good as the topic because but if you check, I'll just explain uh, as much as I know. Like if you check for example, 4 multiples of 4. So it's 4, 8, uh, 12, and it goes on like that. So if you check any number between 4 and 8, like 4, then you 5, 6, 7, 8. So when you divide 4 by, we divide all these numbers by 4, okay? So I want to explain how unit circle operates. Okay. So it kind of operates in this principle. Okay. So 4 are 0. The remainder will be 0. The remainder will be 1. Remainder will be 2. Remainder will be 3. And remainder again will be 0. So the main reminders is 1, 0, 1, 2, 3. These are the main reminders. Okay. We don't consider 0 as a reminder, but 0 is actually a reminder. So what we can do is we can do like this. We notice that after 8 again, we check 9, 10, 11, 12. Check the reminders again: 0, 1, 2, 3, and 0 again. So you see that there's a periodicity in it. So this is being done by reminders. We can check it for any numbers. For example, for 5 also we can do it. But for the thing is that the greater the number, the more the number of reminders will be there, and it'll probably even increase and increase, like increase and decrease. For example, for 5 it'll be 5, 10, and let me just clear the screen. uh, I was just trying to explain the concept between the two, but that's a great question you asked, forcing me to also think. So 5, 6, 7, 8, 9, 10. So again, reminder: 0, 1, 2, 3, 4, and 0 again. So we can see the main reminders will repeat, and after 10 again is 10, 11, 12, 13, 14, and 15. We divide them all by 5. So again, 0, 1, 2, 3, 4, and the remainder will be again 0 again. So what did these guys do? What the mathematicians did? They said, hey, a much easier way is just to draw a circle and just plot those points out. So for for the n, so if you want to divide the number by like 5, let's take the value 4 actually. So if you want to divide 4, the number of reminders can be 0, it can be 1, it can be 2, and it can be 3. But for 5, when they'll do it, it'll be 0, 1, 2, 3, and 4. This is actually one concept I've seen the INMO students use for finding reminders. They find it reminders fast. In fact, all the gold medalist of INMO, he was trying to explain some international IMO, the gold medalist, a gold medalist from the Indian team. He was trying to explain this concept. I not get it as much, but he found a very difficult calculation just by using this method. He just broke down the number and he said, hey, the main possible values for the reminders are this. So he did a difficult division by and fast. You can actually look up that video. IMO gold medalist from the Indian national team, and he actually did this. And so I found that, hey, this is the same method that they're using in the unit circle. This is somehow same kind of method. Oh, here the radius will be 5. So if we take this wheel and we just roll it on the number line at every point where it lands. So assume at the 0 position it will start at 0. So at the ones position it will land at 1. So every point it lands on will be the correct point, where it will be the correct value of what the remainder will give when the number is divided by the radius of the unit circle of the not the unit circle of the circle. So now coming back to the coming back to point. Uh, Now we're coming to understand what's a vector. Now that we understood that what's a unit circle, that unit circle can wrap up all the numbers around. Now what we'll do is simple. We'll just take this unit circle, and we will put it as a stationary point and using a vector. What's a vector? Vector is nothing else but uh, a point that for it's a quantity with magnitude and length. It can be fixed at a position. So what we will do in our case, we are going to fix a vector at a center. I'll just I have to explain. I'll try to explain as much as I can. I'll try not to go over the time also, but I found this topic interesting, so I enjoy speaking on it. So using So we'll use this as a center, and this is a vector. Now we'll use this vector as a like a time clock. So you can go up. I mean the minute second hand in the clock, right? So you can go up or down, but this is fixed. This position is fixed. So that's the main thing. And the now we're going to go and straight use this, and we're going to hit the unit circle, because this will be able to predict every value, because it can go here, it can go anywhere, right? It's fixed at the bottom, but it gives a value. Now we already knew that degrees. Now I sorry, I forgot one more thing. I want to explain what is the difference. So we understood what's radians. We've understood what's degrees. Now the way both of them are numbers, both of them give angles. So what is radians? Radians is nothing else but 2 pi is equal to 180. That's how the formula came out. I've not written this in the notes, but we can find this anyway. We have studied it in 11th class, 11th CBSE. We all study. Uh, 2 pi is equal to 180. Pi is equal to 90 degrees. But pi over here is nothing else but 3.142857. Okay, so that's pi. But this is the number that can be found on the number line. This cannot be found on the number line. Uh, so this is the advantage of unit circle. It helps us to put all the numbers on the number line, on the inside the angle. Okay, and now we coming to the interesting points, that is trigonometric functions on the unit circle. Now we can see over here the sine function is on the y coordinate, the cosine function is the x coordinate, the tan function is sine upon cos. Now we already know from 10th class and all that sine function is from -1 to 1. Tan theta can be is where cosine is not 0. I've taken a picture over here. Over here, sorry, wherever the cosine function over here is pi by 2. So where the cosine is where is 0, it all goes undefined. And the unit circle helps us generalize the trigonometry beyond 90 degrees. I will mainly be using the 90 degrees over here because we all are more accustomed to it, and for me, I find it particularly more easy dividing and multiplying large numbers by with in degrees than in radians, because I find it a little confusing in that. But we'll be able to convert it in the last minute. So I'll just now start the explanation of units. I'll just explain the last point before we enter all the interesting parts, because this is the all the boring part actually, because most of this can be learned elsewhere and by better teachers. But I just wanted to show that the what's coming up, that's more interesting for me. So we have to ask ourselves, I showed you in the previous slide why sine theta is equal to the y coordinate. I'll just show it again. Sine theta is the y coordinate, cos theta is the x coordinate. Now we have wonder why. This is the last question we are asking ourselves before we enter into the interesting parts. Why is sine theta the y coordinate, and cos theta is the x coordinate? So whenever they were teaching us vectors, remember, if anybody can remember, cos, they will say this is the ball object O, it was thrown away in a parabolic motion. uh, in for 11th class and all. So they would come and say this is the f cos theta, this is the f sine theta. I would always wonder, why cannot this be the f sine theta and this be the f cos theta? Well, that's very simple. Why this cannot happen and this cannot happen, but this is the correct values. Well, of course, if they are both at 90 degrees or at particular angles, we can do it, but they are not at the particular angles. In this case, we are all generalized values, so we'll stick with the general values. Sine theta is perpendicular height. We just take this, the right angle triangle, right? Theta, perpendicular, hypotenuse, and adjacent. So sine theta is equal to perpendicular upon hypotenuse. Cos theta is equal to adjacent upon hypotenuse. We know that unit circle has a radius of 1. 1 as so if the radius is 1, so if we imagine we draw the unit circle, radius is equal to 1. I mean this also radius is equal to 1. Therefore, if you draw the line, hypotenuse, the value of the hypotenuse uh, is equal to 1. Therefore, this is going to be p by 1. That's equal to p. That's a perpendicular height. That's this h value. And for cos theta is going to be a value. A by 1, that's equal to a. Now, in this case, because we're talking about it being generalized version, the this r, by the way, is for this entire thing. A value is from here to here. Okay. A is nothing else but the x value. P is nothing else but the y value. So I hope I could clarify it for anybody who will see this video or here seeing this, that that's the reason why sine theta is y and cos theta is the x value. So because it comes out, we just take the unit circle. In the unit circle, we just take this right angle triangle, put it inside, and we plot it out and generalize the values. And hence we can find out that sine theta is equal to y, cos theta is equal to x. And tan theta is nothing else but sine theta by cos theta. We can see it over here. This is a vector. This is the x function. So x bar, x perpendicular, that is the perpendicular value to x, the and the parallel value. Here we can see cos theta is going to be the x. It's going to x comma y, right? So cos theta is the x value, y sine theta is the y value. Oh, here again, sine theta is the y value, cos theta is the x value. I hope you can see this. So this, I hope, clarifies the doubt. Why is y sine theta and cos? Now let's use the unit circle and try to find out the values. Now this comes the interesting point. Unit circle allows us to imagine the whole value. Now we can see the I hope we all can see this. In fact, I've in the back, in the down later parts of the ppt, I've shared all this. I'll just show it. I've shared uh, all these links. I've shared it over here, some YouTube links. If you want to learn more, I will share it. And I'll share it all these after this lecture gets over. You can definitely check it out. It'll be fun for you guys to just expand your knowledge base and try to think like how, what would this angle be and all. So I'm coming back to topic. This is the demonstration. So if we take sine 0, we can see the graph on the floor. Sine 0 is 0 because that makes total sense. The y value at this value is 0. So if we go slightly above, we can see y value is increasing. As we go towards the 90-degree value, that is over here, we are using we're using degrees at the 90-degree value exactly. 90-degree value, the sine is the y value is at the maximum position. That's 1. That's why we are getting sine theta as a 1 as the maximum value. Now then we proceed to increase the theta value more and more and more. Still the sine function is greater. Now this is very important to understand that the value of sine is nothing else but the y value. If this y value goes above a certain degree, then it all becomes negative. So that's why when we go and we say sine 2 pi, if we check the value over here, the values of sine 180 between 180 and 360, pi and 2 pi is all negative values, because the value of y in that region is negative. Now see, I am not I'm going to just increase the value of theta, but I'm actually starting all over again. That the reason comes in the gain when I explain the unit circle. the values are periodic. So all the so I told you that it goes from 0 to 1, 0 to 4, and then again to 8, like that. So same way over here, it started from 0. We can check it. It went all the way to pi. It all the way to 2 pi. Now we'll again go all the way to 4 pi. As we can see, the values are all starting, they're all the same position. Now we can go in the reverse direction also. That's the beauty of this thing, that we can go both front and back. We can imagine as a wheel, or imagine as a function that gives out a value. So that's the beauty of this unit circle. So as we increase, goes towards pi theta, the 90 degrees, it goes to max, it reduces all the way from 180 degrees, then it goes to towards 270, and it reduces all the way to -1, again 0. Then it continues. So that's why the value of sine theta is always constant. And over here the point went off the screen, but when we reduce it again, we can do the same for the cos function. Actually, the cos function is nothing else but the sine function. Only the thing is that at the 0 value, what's the value of x? At the 0 value, the value of x is at maximum position, that's 1. As we go towards 90 degree, the x value keeps on reducing. Keep an eye on the blue tag. Actually, over here the green arrow, and over here the sine function of the green arrow, and over here the blue arrow. As the y value is increasing, the x value is reducing, is reduced. There's no more x value. Now it's the negative x that is increasing. That's why, the as you see in the function, it's going down. And that's again reducing. But actually in this case, we can call it increasing, because it's a negative x value. But anyway, the magnitude is reducing. Now the magnitude is increasing, and again at 0, it's the maximum position, 1. So that's all for that. How basic now. For tan function, actually we can check it out. When the x value is at uh, 0, then only the y value is there. So therefore it becomes 1 upon 0. We can check it out. 1 over here, 1 upon 0, that's equal to plus minus infinity. So at the only value where both y and x are equal, as that's the point where they are having the 1 as a value. Now if you check on the side over here, there's written angles, right? Over here, this is the way we actually can find out large angles. I'll just convert it to degrees. Over here, see 420 degrees. But when we convert it to radians and all, we can in degrees also we can do this conversion. This is how we actually do the main large angles. So we can just keep on rotating it. We have gone quite a bit, and we check the degree value, like 2400 degrees. Wow, that's a huge number. But when we convert it down, it's just 12 pi plus 4 pi by 3. So it's such a simple number. It looks I'll just get the cost value. It looks such a uh, this looks such a simple computation, but when you check it out, oh my god, many people actually we get scared when we see such a cost 2400 degrees. We say we don't know cost 60 degrees properly, but cost 2400 degrees. But by using unit circle, we'll be able to easily identify and find out the answer. So that's all for the unit circle. Now we come to the last we're coming to the closing part of this whole thing, and uh, I'm going to explain the topics of one of the main topics. Like many people, if they choose to come over here, will be just to find out, because I especially had, I told you all earlier, I had especially had a difficulty in finding out these kind of weird values of like sine theta plus pi by 2. What is this? And I had like, I especially faced a lot of difficulty in my 11th class in finding out what these values are. But God's grace, we had great teachers and they explained it. So like that same way, cos theta, like now cos, assume theta to be 4 pi. So 4 pi plus uh, 5 pi by 2. What's going to be this value? This is like a difficult, actually it looks quite difficult, but it's actually not. So this is what I want to explain. So I'll just write out some main points. I've not written it in our slides actually. If I check it out my slides, I try to explain the unit circle. Over here, some unit circle radians. I'll just tell this and we'll move on. Some unit circle radian charts. Over here, I'm trying to explain that cos 0 is equal to 1 at 0 because cos is the x value. Over here, cos is going to be 0, but sine is going to be 1 because sine value over here is at maximum. And that's it. Now we are trying to find out we knew that at 0 degrees cos is going to be 1 because cos is 1 and sine is 0. Cos sine 90 degrees sine is 1 and cos is 0 because it's like that. And I hope you guys got it. I've sent some video links in the last so that you guys can see. But these are some important angles. And we saw them all in the units. We all saw them in the uh, actually in this over here. If we check it all out, I'll just go back to here. So this is 0, this is 90, 180, 270, and 360. So I hope you guys got it. This is how we do it. I'll just coming to the closing part of this, kind of the we have now finished no most than half of the topics I wanted to talk on. Now it's just now only 2 3 topics are left. That is finding some angles, uh, then even an odd function, and then last but not least, graphically proving sine square theta plus cos square theta is equal to 1. That's I found it quite interesting. But now we have come to the closing part, so don't worry, guys. I'm not going to just extend the lecture for no reason. But now coming to these points, and let's up to understand there's some basic formulas we got to basic rules we got to keep in hand. This was explained to me by a sir in an academy. Unfortunately, I forgot his name. Sir, he passed out in IIT Roorkee. Samir Chanchodi, I don't know his name properly, but he explained it to me, and I really loved it when he explained. And Tarun Khandelwal sir from Physics Wala, he explained. So these are for sine and tan and their inverse values. I mean, their other their other values, that is 1 by sine and 1 by cos. That's going to be cosec and cot. For them, these are the main rules that will follow. Actually, for all, but we can actually call it for all, for cos, for sec, for uh, cos and sec also. So all the trig functions over here. First, whenever it is theta plus pi, any value. So for sine will remain the same function will remain over here. Now what happens to this will give a output of it, but whenever it comes in the multiples of pi, so it will be theta plus n pi. So the trig function actually over here, the trig function will remain the same. Okay, whenever it comes in the multiples of n pi. But suppose it comes in the multiples of n pi by 2. Suppose sine theta plus n pi by 2. Then we are going to get its complement function. So for sine, it will become cos, whatever function will come out over here. For I'll just go right on the top over here. For sine, it will become cos. For cos, it will become sine. For tan, it will become cot. For cot, it will become tan. And for sec, it becomes cosec. And for cosec, it becomes sec. Okay, so these are the complement functions, and they will interchange when this occurs, when n pi by 2 is involved, when pi by 2 is involved. Okay, so these are the first two rules that are important. I hope you all make a note of this, because this will be a little handy. This is actually quite handy, this rule. I would love you to all to like take a note of this or see the video again if it comes on YouTube, just to understand it.
Yeah,
uh,
yeah, Philip. So
okay, now End in the don't worry, I'll just end as soon as possible. Now it's for this last part is this. uh, Theta, whenever we want to, now sometimes this is 90 degrees actually. Wait, let me just, whenever we, for example, for sine, we know value of sine is y function, so y is always going to be positive on the top, and x, and it's going to be negative on the datum. Same way, x is going to be positive over here, and it's going to be negative over here. So whenever we extend it, so theta is a positive value. Whenever we get, like suppose we did theta plus pi by 2. So for sine theta plus pi by 2, I told you the first rule is to convert it to cos. Now over here, what's the value of sine? What's the value of this trig function? If it's positive, then we just say positive, and we just add the value of theta over here. So it's going to be positive cos theta. But imagine this is cos theta plus pi by 2. Same function, they both complement, but over here when we check over here the value of cos is in the negative because this is the negative x value, so it'll be minus, and first formula, first rule, will be sine and theta, so there will be minus sine theta. Same way you can do it for many other functions. Check it out for tan and cot, and just imagine, I'll just try it for sine theta plus pi. So whatever I do, whenever I get these kind of values, pi plus theta and all, I just extend. I know that this is 0, pi by 2, pi. So I'll just imagine theta as a small angle. So I'll just draw theta over here and say, hey, what's the value of sine over here? Well, sine is this is in the negative direction, right? So I'll say to myself, okay, fine, this is in the negative direction, so it'll be negative, and because it's the based on the first rule is n pi, right? I mean n pi, so it'll be sine, and hey, this is in the negative value, so it'll be negative and theta. So that's how we do it. Okay, and we can actually we can. I'll just clear the screen fast, and we'll find that just 2 3 more points before closing. Uh, just imagine sine pi minus theta. Now, same thing. First, draw the line. This is pi, right? This is pi by 2. So we say, hey, pi. If you want to add a number, earlier only I told all the positive numbers go in the anti-clockwise, all the negative numbers go in the clockwise direction. So negative meaning this way, so this meaning this, so hence, and anyway we also know that theta, when we go, this is increasing value, pi by 2, then pi, when we go reduce it from pi to pi by 2, it goes this way. So this is pi, so if we reduce theta to this will be the angle, right? The remaining angle is going to be this entire angle is pi, but this is theta, so this will be pi minus theta. What's the value of sine over here? Well, sine is positive, so this is going to be positive n pi value, so sine theta. So you guys, we can check it out like this. We can do it for more more crazy functions, and we can actually check it for many angles. Now we're coming to the last point, the second point of my thing. So I'll just explain one small concept of large numbers. Whenever we get a large number like 2400 degrees, so what we do is first convert it to, divide the whole number to 3 by 360. So when we divide 2400 by 360, I've calculated over here, I'll just do it fast. 2400 divided by 360, I can see that it's not giving out the exact value, so that means it's not giving a proper value. So I realize that, if I draw the number line 2400, this is going to be 2700, so, and this is going to be 1800, so 2400 is going to come here somewhere. So what will I do? This is just a random guess. Why? Because we have rotated the circle 10 times. That's how we got the value of 2700. This is 900. This is 0. Okay, 0 will always, no matter how many times you rotate it, it's going to be, the all will be 3600. So these are some ways you'll just keep on repeating, solving the question answers, you'll get it. And over here I find sine of 2400 degrees. Now I know that this is 1800 degrees, so I'm going to do sine 1800 plus 2400 will be 600 degrees. So this will now come be, I still don't know the value of 600. So actually we'll try to do it in a much easier way. So 1800, why don't we try to do it like this? 3600 minus 2400, 1200. So
Yeah,
we
dividing
have
by
to find out,
360.
dividing. Oh, okay. So anyway, the main way, actually the main way, the main way you do it is you get this large number and try to form it as a I'll leave it up to you guys at multiple of 360 when you're doing in degrees.
360. Yeah.
And when you, yeah, so when you get into multiples of 360, you will be able to take all that value. So for example, to 2400, uh, it'll come, it's coming out as 6.66 when we divide it. So it'll be some, I assume, I just uh I one second. uh I just find out right now, because I am, yeah, I was
Y-
correct about this. It
Yeah,
is
let's
coming,
see in
it is
the
coming over
filling.
here.
Actually, it's going beyond of,
Okay, fine. Okay, fine, fine.
9.
Sure. I'll just cut. Sure, fine. I'll cut
Yeah.
it. I'll cut it. Cut it. So anyway, it's when we get in a multiple of this, we can totally erase this value to 0. After that, whatever remaining we have the value, we'll just put that into the unit circle and we can derive that value. Okay, that's the main point. I've left some YouTube links in the end. Uh, Our YouTube links in the end. I just want to explain one small point. I want to explain one small point before going, and that is just proving sine square theta plus cos square theta. How's it one? And that's the last point I want to explain. That's, I found the most interesting point. That's the only point. So I hope you can see the screen. This is the only last point I want to discuss. So sine square theta, because it's a positive value, all the values will become positive, and cos square theta. Uh, uh, Cos square theta also is a positive value, hence it goes up. If so, for example, y is equal to cos square theta, uh, and I square theta. I would really advise you all guys to go to Desmos and try it out yourself. But this is the main thing you can understand it how. Okay. Oh, here's the value of, you can see the graph. All the graph has gone upwards. Usually the graph will be from -1 to 1, but over here it's called compressed. We can see these values, they intersect, and if we can just do it graphically, it's just simple. When we just add two numbers, like over here we can, I'll just show you one last thing. Y is equal to r plus 2. So we can, y is equal to r is equal to r, at that time it will be 0, 0, but when you add plus 2, it goes above. Same way, y plus, so whenever we add two functions, they can be added properly. So the same simple way of why, how they found that value of sine square theta plus cos square theta is equal to 1, graphically I'll just say, is that at this value 0, but at this value sine is going to be 1. The cos is going to be 1, sine is going to be 0. But at the center is both are equal to 1. So this is decreasing and this is increasing. So hence both of them, whenever they are added together, they will both always end up at 1. So this is the way graphically, actually, I know I was trying to find out, my sir had asked us to check it out. So we were checking it out and we realized that, hey, every time cos theta will reduce its value, sine theta will increase its value, hence it will remain a constant line. This is the one of the most perfect, actually perfect ways. They both are always keeping themselves in balance. They're always keeping themselves in balance. That's why we'll get a constant value. uh, and that's how we can actually prove sine square theta plus cos square theta is equal to 1. Guys, I wanted to share much more, but unfortunately due to time constraints, and I got really too interested in explaining about the
Yeah.
unit circle that I forgot about the main topics. But actually you guys now can go further, I've shared the PPT. You guys can Shubham Moria, sorry, will explain. Can send this out, and you all will be able to explain. Thank you guys for
Yes.
watching.
Yeah, I will spread out. Thanks,
Um,
Philip. And yeah, it's really great explanation. Really great. I have actually watched all. So yeah, it's really great. Uh, okay, actually, it's going beyond of 9, 9, 10, 10 minutes is more even.
sure,
So, okay,
sure, sure.
thank you
I
so
totally
much.
forgot the time.
Okay, Philip. Yeah, yeah. Okay, thanks.